Hey guys, as much as I would have loved to done an amazing skit for you, I kinda got a little busy. So instead, I've got these little drawings of me that are going to help you figure out exactly how to solve this math problem. First, we're given this equation, and the question they're asking us is to figure out at what places is it decreasing, is it increasing, and if there's a max, where exactly is it? Well, in order to find that, we have to get our equation and take the derivative of it. There we go. And now we're going to go ahead and take the derivative and set it equal to 0 and solve for x. We're doing this so we can find the critical values, because at the critical values, it's where the slope of the graph equals 0, which means that the graph is changing directions at that point. So this can help us find out where the graph is increasing and decreasing. Doing this is also called the first derivative test. Presto changeo? There we go. And now that we have this, if we factor it down, we should be able to get it into this simplest form. And that is going to tell us that x is equal to 5 and negative 8. And hopefully these will be points in which the graph is changing directions. But we can't be sure. These values are just candidates. They might do it and they might not. So we're going to take these values and put them in this spiffy little line graph I made. As you can see by my marvelous color coding, we have three sections of this graph to worry about, from negative infinity to negative 8, in between negative 8 and 5, and from 5 onwards to infinity. In order to continue solving this and figuring out what's going on in each of these sections, we need to take a test point, or just a point anywhere in between these three sections, and make it equal to x in the derivative. What's this going to tell us is it's going to tell us the slope of the function. And if it's greater than 0, the graph is increasing. And if it's less than 0, then the graph is decreasing. Now, with the marvels of movie magic, I'm going to go ahead and solve for these points that we've chosen in only a couple of seconds. Magic over. But now that we have those numbers, what exactly do they mean? And my page is getting a little messy, so let's go to a more organized setting on the next page. Now you guys can clearly see which one of these are greater than 0 and equal to 0. So now we can label accordingly. This section is increasing because the answer was greater than 0, as well as this side, because the answer was, again, greater than 0. But in the middle here, our answer was a negative number, which means in this section of the graph, it is decreasing. In order to figure out if there's any sort of maximum or minimum values within this, we're going to have to take the second derivative of our function. Here's our original function, and if we take the second derivative of that, it's going to give us 12x plus 18. In the same manner that we did the first time, we're going to go ahead and set this equal to 0 and solve. In order to solve this problem, we're now going to apply the second derivative test. And we're doing this because of this wonderful little theory given to us by our professor, which states that if f prime of c equals 0 and f double prime of c is greater than 0, then we have a local min at that point. Likewise, if f double prime of c happens to be less than 0, then we have a local max at that point. The only time that this will not happen is if f double prime of c is equal to 0. In that case, it fails our derivative test, simply because these points were all candidates, whereas in the first derivative they're critical points. In this second derivative, they are points of inflection, meaning that at this point it is changing directions. So it has to be a max or min, unless it's equal to 0, in which case we don't care about it. It doesn't matter. You're not important to me. Now that we know this theory, we're going to go ahead and go back and plug in our critical points, which was x equals 5 and x equals negative 8, into f double prime of x and see what that gives us. Time for a little more movie magic. Thanks to this information, we can finally finish off our graph. And it's safe to say that at these two sides, it's increasing. At this middle point, it is decreasing. And at the point negative 8, we have a max. And at 5, we have a min. And that, with only a few seconds to spare, is how we do the first and second derivative tests.